My name is Arun Singh and I work for Adobe as a SRE team. So first of all, people who don't know what SRE profile is, so we are the people or we are the team which actually takes care of availability of our application. We are responsible for the availability, scalability and the architecture side, the new technologies that we involve into it. So we are the people which takes care of all these things. So first of all, I would like to know how many of you guys are from SRE background, DevOps, or have any experience working on the server side. Okay, yeah, few of them. Okay, so for people who have experience with working as a SRE profile or on server side, so most of the time you guys have faced issues, or you guys used to be on call, you guys be taking issues in your night time also. I guess everyone has faced it, right? So, so this is what happened with me. I would say around a year ago or so. So when I used to get called in night saying that we got this alert and you have to fix it, the alert came to us. So what we have to do, we have to wake up at night. Then we have to open up our eyes first. Then we open up our laptop, we SSH, then we run some certain command. So most of the time what happens, we are running a certain command. There is a step that we have to follow to resolve a problem. So there's always a particular step that you have to follow. So that was my biggest concern. So I thought, what I am doing is I am just doing the same thing again and again in my night time. I'm screwing my night life. So that I didn't want it to. So the whole and sole purpose of designing this workflow was that if you get any issue which has a list of things that you have to do to resolve the problem, then why you are doing it? Why not machine do your work? So this was the main concept behind it. So I would like to start with the agenda first. So I would be explaining first of all the problem statement. So why we started thinking about this, why we started doing or investing our time in auto remediation. Secondly, there are some prerequisites that you need to know so that you can understand this session much better. So these are going to be very basic things, so you don't need to be much worried about it. Next, what is auto-remediation? So the general term, what is auto-remediation? So I will explain what it is. And moving forward, the pillars for auto-remediation. So when you start thinking about designing a workflow, designing architecture, there are certain things that you always take care of, which are the pillars. So I will explain that also. And then the general auto-remediation workflow, how things works. After that, I will move forward to the salt stack. So salt stack is the core engine behind this complete workflow or complete architecture. So I will explain what salt stack is. So I was guessing that most of the people don't know about salt stack. So I have kept few slides for salt stack also. Then I will discuss the architecture that we are following, that we have designed. Moving forward, the steps that our complete workflow is taking, starting from the issue comes and the issue resolves. So I will explain them step by step. Then the good part. So what the achievements we had after designing all this workflow. So this is the very important part. And the future prospects that we are thinking how we can improve this. So this is on the initial level. This has been just started. There is a lot we can do with it. So I will just explain what my ideas are and you can just take it to your next level. Okay, so moving forward, problem statement. So the first and the biggest problem statement was sleepless nights. So I never want my nightlife to be screwed, first of all. And I guess nobody else wanted to. So the issues that usually came in my night time or I have to just go and check to it, that was the biggest problem that I faced and I started looking into this. Second thing is human errors. So there is a huge difference between a human doing a work and a machine doing a work. So it's like human can do human, it's human nature to do some mistakes. So sometimes I have also done it. You call it a fat finger mistake, or you call it sometimes you are feeling sleepy. Instead of one server, you end up running commands to some other server. So it happens. It's a very common thing. So that's the second thing we are covering. And third is productivity downgrade. So if you're doing one thing again and again, again and again, and so it doesn't make sense. You are just spending your time into it. Or what you can do, you can just make your system do the work for you, and you can save the time and you can invest that time on different projects or on different or improving the current project that sorry that you have. And the alert fatigue. So, so when you are working with 10 servers, 100 servers, 150, 200, it's okay, you can manage it. But when it comes to 1000 servers, so Adobe has an infrastructure huge enough to have 50,000 servers. So if one server has one issue in 1 hour, so you can imagine how many problem you can get in one day. So that's the alert fatigue that we want to resolve. And last but not the least is writing runbooks and analysis or documentation or root cause analysis, whatever you guys do. So documentation is the one part that people don't usually like very much. So it's like whenever there is a problem, even the problem is very small, it could have been resolved with a simple restart or something, but it's causing a customer impact, then you have to write a complete documentation to give to customers saying that this was the problem, we resolved it, and blah blah. There are lots of things that you have to write and present to it. So, so that will also save times. Moving forward to prerequisites, so there are certain things that you need to know before before you get a bright picture of what I am presenting. So first of all, the basics of Python. So the basic, I am talking about the very basics. So it's like you need to know how to run a script, you need to know how to run a function, module, just that. And second is, since our core engine behind the auto remediation is SolveStack, so you need to know what SolveStack is, the basic commands, what SolveStack do, some terminologies that I am going to use, so you will get a better picture of it if you know what SolveStack actually is. Anyways, if you don't, then also I am going to explain what those terminologies are, and if you guys feel alien words anywhere, you can just raise your hand and ask me. Uh, one more thing is you need to have some understanding of monitoring, how monitoring performs. If you have an experience with any tool, basic is Neguis, but there are different other tools in the market. So if you have experience with how monitoring works, then it's a plus point. So what my topics revolves around is auto-remediation. So what is auto-remediation? So the word, what the word explains is auto-remediation or self-healing is you get something, you get some issue and it get resolved by themselves. So this is the one-liner. So if you go into some technical terms, so auto-remediation is basically a workflow which triggers whenever there is a problem with your system or a particular server, and it ends up when you actually fix that problem. When machine actually fix that problem, not you, so it will get auto-remediated. So auto-remediation can be very simple and can be very complex. That totally depends on you and your criteria, what you want to satisfy with that. So the easiest example would be to restart a particular server, particular service. So it could be your application based service, it could be Django, it could be Nginx or Apache, any a particular service. This is the simplest and the smallest example that you can do. So if your Nginx fails, let's say if your Nginx fails, so you won't like if you have to wake up at night and you just have to, what you have to do is do service Nginx restart. So that's the very bad thing that you have to do. So this is the simplest example, but moving forward, what you can do, you can write your own Python modules. You can say in application that, okay, so first, so what, whenever a problem comes, what you have to do, you just have to tell computer that you have to do the same. So let's say if my application fails, what I will do? So first I will go to the logs, I will check what are the logs, I will search for a certain thing. So if this thing is present, then I have to do this. If this is present, then I have to do this. So there are certain scenarios that you follow. You just have to tell your, you just have to write it in your module that go parse the log. If this error comes, then you have to do this, and this is the steps that you have to follow. So starting with a simple service restart, and you can include multiple modules, not one. You can call different modules from one, or you can resolve a complete entire problem which you can have in your application. So this can resolve the problems which you are having on your service or your server level. Also you can resolve problems with your application level. So sometimes basic problems with the coding also you can resolve with it. The indentation problem sometimes people get, or there are different problems that when you parse the log you see okay, this package is not installed, that's why my application is getting failed. So what you can do, you can just catch the log file, you can see this package is missing, and you just install that package. So yeah, so ideas are lots more, you can implement whatever on it. So moving forward on the pillars of auto remediation. So the pillars which we thought when we started working on this workflow, first of all, detect problem. Your monitoring comes into picture in this. So detect problem could be, you can do it with different scenarios. You can use any monitoring tool. You can use Nagios, Graphite, Grafana. There are lots of them in market right now. You can easily do it with a shell script also. You can write a shell script, it will check different scenarios in your application and if it's working fine or not. So it could be anything. So first and foremost, detect problem, detect failure. Yeah, then second is notify the system of failure event. So the system here is auto remediation. So it's like you are notifying auto remediation that okay, this problem has been occurred on this system. Third thing is the system listens to the failure event and it responds with some remediation actions. So first of all, start with detecting problem, then sending it to your system, then your system should respond on particular event. So it's like if this service has been failed, then you have to do this. So these kind of things. And then moving forward, the also one important thing is you must log whatever you are remediating. So what happens sometime, so auto remediation right now, what auto remediation is, it is not very intelligent. What it's doing is you have told him that if this comes, run this. So when you start logging and analyzing the problems into it, so we are planned to introduce artificial intelligence and deep learning into it, but that's a future prospect. For now, you can say that auto remediation is just you say that when this problem comes, you have to do this. So how logging helps into it? So with logging, if you create a dashboard and when you see that dashboard after 5 or 6 months, you can easily find out that these were my 5 servers which were alerting a lot, or these were my 5 services which were getting failed a lot. So you can easily analyze the pain points in your architecture and you can directly trigger, or you can directly go and improve that particular service. So this is where loggings come into picture. So general auto remediation workflow. So what happens, alert triggers. So there could be only two possibilities with that. Either you know what that problem is or you don't know what that problem is. So if the problem is new, you don't know about it, then obviously it will go to the notification channel that you have, PagerDuty or whatever you guys must be using. So you can just redirect that alert directly to that notification service and you will get notified by email, call or whatever. But if you know what that problem is or you have already faced that issue earlier, you can write a auto remediation for it. And so after writing auto remediation also, there comes two scenarios. Either your auto remediation works or your auto remediation fails. If it works, well and good, good sleep. If no, then you can also redirect that to your PagerDuty account, or you can mention in the auto remediation also, so that if it fixes the problem, then it's good. If not, then create a ticket for me on Jira or any other thing that you are using for ticketing. So you can just tell him that if auto remediation fails, create a ticket to me with all the details that I need. So when you go in the morning to check that problem, you will need some details like last 100 or 150 lines from your logs, what was the memory at that time, what was the disk space at that time. So the general things that you will see before resolving the problem, what you can do, you can say auto remediation that if not fixing, send me all those things so that it helps me in resolving that problem in my business hours. Okay, so SolStack is exactly the same. It's a tool which is used for remote execution and configuration management, just like other tools too. So why SolStack? So we have lots of things in market. We have Puppet, we have Chef, we have lots of other Ansible and different tools. So why SolStack? So SolStack is first of all, it's an open source and it's entirely completely based on Python. You can change the core of SaltStack to leverage what you want. This is not available in Puppet or any other tool. This is very easy. As you know, Python is very easy to learn. You start in the morning and evening, you can write module. So it's like that. So SaltStack is exactly the same. So you can easily learn it. And so in SaltStack, three basic languages are used. YAML, very simple. Python, very simple. And then Jinja. Jinja is also a part of Python, you can say. It's very similar. So these are the only three things which has been used in SaltStack. So SaltStack is very easy. It's very fast. You can get up and running with SaltStack in minutes. So I will give you a demo, and after seeing the demo, you guys will say this is nothing. You have done nothing. This is very easy. So this is, and it's highly scalable. Highly scalable. Personally, I have been running it on 30,000 servers, and this is working exactly what I wanted it to be. So this is very fast, very scalable, and very easy to learn. So that is why we are using SaltStack behind it. Now moving forward with the architecture of SaltStack. So there are lots of things in the SaltStack. There are runners, there are reactors, the basic core engine. So event bus, you can have minions. So in this there is a term called master and minion. So the master is the one which takes care of all the minions, you can say, all the servers. So you run everything from master and it get executed on all the servers. So you can have Windows Server, Linux Server, AIX network, whatever you want to integrate with SaltStack, you can do it. There are lots of things, but what I am using in my workflow, I will explain you that also, because if I start explaining all of them, then probably it will take, I will end up tomorrow. So first of all, the sending event from minion to master whenever a failure occurs. So there is a functionality in SaltStack called event. So what event does is it runs on salt minion. You can send any information from salt minion to salt master, and you have to just say that when this criteria happens, then send this message to salt master. So that what event does. And there is a functionality called reactor. Reactor's responsibility is to react on a particular event. So whenever an event get triggered from minion to master, reactor has to respond on those events. So that's the core functionality of reactor. Event bus that you are seeing here. So event bus that you are seeing here, so it's you can compare it with RabbitMQ or Kafka. It's just a messaging service between Salt Minion and Salt Master. This is how they communicate. So all the communication between Salt Minion and Salt Master happens on TCP. And it's faster. It's faster. That's just I wanted to say. So the key terms here are reactor, event bus, event, and one another thing will be scheduler. So a scheduler in salt is a functionality to run particular salt state or particular command or anything in a given period of time. So you can compare it with cron. So the functionality that cron provides is the same functionality that scheduler provides. Okay, so this is the architecture that we are following. So in our architecture, what happens? So step one would be to get notified, as I said. So we are running different Python scripts on all of our salt minions, which goes into our deep into our application and checks every scenarios. And whenever there is a failure occurs, it sends an event to salt master. So first step is that minion executes on local minion. So there is scripts executes on minions which detect the problem. Second is on failure, minion sends a event to salt master. And the third step is salt master reacts on those event. with a reactor or a orchestrator. So orchestrator is something with the name it clears that it runs on lots of servers and it can resolve problems on multiple servers at the same time. So this is how the workflow is. Also, whenever we trigger a reactor, we also send a notification on Slack. So Slack is a communication, it's like WhatsApp or whatever, so people who don't know. So it's simple, it's for in technology or in companies we use Slack for communication. So we send event or the messages, whatever an event has, to Slack just to notify us that there was a problem with this particular service and auto remediation has resolved it, just for your knowledge. So if we move forward, here are all the 5 steps that happen. One, Salt Minion recognize an alert through any monitoring tool. It could be NagOS or any monitoring tool, or it will just send an event. Second, it sends an event with minion ID, so the name of the server, the job, which service got failed, so it sends all these information. I will explain you guys later about that. And master responds with a reactor. Then we send some remediation from the master to minion to resolve that problem actually, and then we do the logging. Simple enough. Moving forward with the example of salt event. So is this visible to you guys? So this is the message that comes from salt minion to salt master, and you can see right here that you will see the host name. So this would be the host name that would be provided, so that master knows that which minion got failed. And in the messages, it's the you can see the service name, then fail, so that master knows that this service has been failed. Okay. Okay. So moving forward, just a second. Yes. So this is my salt master. I have prepared a salt master and minion, 2 VMs that I have. Okay. Yeah, so I have prepared a master and minion infrastructure for you guys. One VM has master and one VM has minion running. So font size, okay. Just a sec. So it's a VM. It's not my system. Okay, so I'll just bring it up. Okay, so I've just run this command just to make sure that whatever event I am getting, I am able to show you guys. So this is our salt master. If we go to salt minion, what I am doing right now is I will just stop HTTPD service. So as I said, I am giving a very small example, which is I am stopping a service, and this will get started again after some period of time, and then I will show you how I did it. So I'm just stopping the service. It will take 1 minute to get it up. So how I am doing it? First of all, as I have said, first thing is you inspect what going wrong on minion. So if you go here, so I am not sure if it's visible to you or not, but this is how I am monitoring. So I have one script on my minion in root, which is check HTTPD. So what that script is doing, that script is checking if the server is, if the service is up or not. So if I go and if I just get that, Okay, so what this script is doing, it's just checking if the PID for HTTPD is available or not, or there is a process for HTTPD is running or not. So if it's running, then it's doing nothing. It's that HTTPD is working, and if not, then what it's doing, it's sending a salt call with a particular tag. The tag is company slash product slash check HTTPD slash the service name and the fail or pass that you want to say, and the message is HTTPD not working. So this is a salt event that minion is sending to master, and when you see on master, so this is, yes, so just give it some time. So what will happen is it will make sure that your HTTPD service is running or not. If not running, then this event will get triggered and the auto remediation for that will be in place. So I'm just checking if. So it will take 1 minute. I have given the time for 1 minute to run it. Meanwhile, I'll just make sure that my IPs has not changed. Yeah.
Start with the QA, and you can show the code also. I mean, same time.
Okay, thanks.
Okay.
That's it.
Yeah. Also, I have very less time left, so I'll just give you some examples of the modules that we are using. So, this is the most important thing. Salt module. So what I was showing you guys was to restart only a service. So what if there is a bigger problem? So you have to do lots of things before you have to analyze lots of things before you run any command on it. So you can write your own salt modules where you can mention everything in your application. You can mention that check all these things, and if then the problem, you will see that this is the problem, then only restart the service. If no, if there is no problem, then don't do it. So there are different salt modules that you can write. What I wanted to say. So these are some examples of salt modules that we have written for us. Uh, just taking an example, this is one of the code which we have written. So yeah. So this code is actually used when we get alert from our RabbitMQ saying that your queue messages are very high. So what we do is we have told auto remediation that just go into that server and give us a list of all the pipelines or all the queues which has the highest number of messages, which is the most important thing you need when you start troubleshooting it, right? So this is what I was saying, that you can gather information if your auto remediation is not working, and you can just put it somewhere so that when you start looking into problem, you will have all the necessary items with you. So this is how we this is how we communicate. So this is the messages that we get from salt minion whenever an auto remediation is run. So it just says that there was a problem with this particular host name, this service was down, and it has been taken care of by itself. I was telling about giving the doing the analytics when you push all the data into one place. So when you see after, so this is the stats of 24 hour. So you can see, you can easily just look into this, and you can see in 24 hours you got 9 alerts on this server. So there must be something wrong with this server. So the problem has been resolved by itself, but you get a concrete, or you get a pinpoint that yes, this server was faulty and I have to go and fix this. So this gets very useful when you start troubleshooting and digging deeper into your problems.
We need to finish it.
Yeah, so I'm just finishing it up. So this is the analytics dashboard that you can see, which has all the details. So coming to achievement, so after implementing this, we reduced our alerts more than 40%. So earlier we used to get, let's say, 100, now we are getting only 650 or 60 problems in a day.
There's another talk, Arun, please.
Okay.
Try to understand. We have some limitations.
Okay, so we have lots of lots of achievement with this.
Probably people can, who is interested, they can get to him.
Yeah, yeah. So, okay. So anyways, people who are interested to learn more about it, so I would be sitting for next 15 to 20 minutes on the Adobe's space that we have in the ground floor. So you can just catch up with me.
Thank you, Arun. Thank you.
Thank you.